Okay, so we're off, still in our logarithm sort of chapter. This will be the last day of lessons. Tomorrow we'll just answer homework questions. The next day I'll have a sheet, a practice test sheet due for you, and we'll just see where we are. Today's all about money. So here's the equation that rules your money sort of stuff if we're getting interest on an investment. Anybody care to guess what any of these letters stand for?
Amount?
Yeah, that could be the amount of money that we're going to have like later on down the line whenever we cash in.
I know
this is what we're going to get.
Interest plus rate, and then
this is going to be an interest rate.
And it's
anytime it's given to you as a percentage, we like to create instead a decimal. So we're going to make that conversion.
T time?
T is time.
And then P is principal.
P is a thing called the principal.
You need that because you looked at the paper.
Whenever you invest money, what is the principal? What does that word mean? Anybody know anything about money? You invest some money, there's a thing called the principal.
Is that just like the starting amount?
It's your starting money. Okay, so there's three things that affect how much money you get out. One is the principal, how much you put in, and obviously that would be important. One would be the interest rate. If you go to the bank and open like a savings account, they give you less than 1%. Okay? If you went and you put money in the stock market, on average, an average stock market year is like 8%. There's other investments you could get. There's a thing called a CD. If you went into the bank right now and opened a CD, I think CDs are about 5%. Okay, what happens with a savings account is you could get that money when? Okay? Whenever. So if you opened up that account today, you could take out that money as soon as
you open it
today. You could leave the bank, go back in, take your money back out. You wouldn't get much interest, but you could do that. CDs, you sign up for a term. The 5% CD would probably be like a 1-year term. So you'd say, here's my money, you can have it for a year, you come back in a year, you could get your money back. If you went in early and said, give me my money on a CD, they'll say, well, here's your original $5,000, we're not giving you any of that interest. Or if you waited 11 months, they give you some of the interest. There's penalties for that. Stock market, you can take stuff in and out of the stock market anytime you want. There's no set thing there. Anybody know another sort of investment other than bank investments or stock market thing, another common investment thing? Starts with a B. Stocks and B word.
Bonds.
Bonds. Bonds are kind of like CDs. There's like a term you sign up for, 1 year, 2 years, 3 years, 10 years, whatever. Some of you, when you were born, I don't know, maybe this happened. My kids, both of them, when they were born, people gave them like these savings bonds. They're like 18-year things. So I think yours was like $100. You wait till you're 18, it's worth $200.
Wow.
So it doubled. It's decent, I guess. But there's a thing called bonds out there. But the rate you get matters. If you have money parked in your savings account at your bank at less than 1%, it's almost like having it under your mattress. Like it's not really doing anything for you. But if you're getting 5%, 8%, it could matter. T is time. The time obviously matters. If you let your money just grow longer, it's going to make a difference for you. But that's the equation. So for this sheet, just getting the right numbers in the right slot, we're gonna just try to run this math. So for this first line, I'm saying $1,000 principal. So that goes where? After the equals. Interest rate of 7%, you would turn 7% into 0.07. So what's 1 plus 0.07? 1.07. Then the time?
25 years.
25 years. Before we push any buttons, 7% is like less than stock market average over time. If you had 1,000, you dropped it in there, you came back in 25 years. Anybody want to guess what would be there? $1,000 today, you come back for it in 25 years, the stock market's going to be below average. Guess?
Oh, it's below average?
Yeah, it's a below average stock market, but we're putting in $1,000 now. You come back in 25 years, how much money do you, just make any wild guess, how much money you think you have?
$17,000.
Yeah, I'm gonna say something, like 15.
So let's punch the numbers and see. This is our variable. So we would just punch in 1,000 times 1.07 The power button again is probably that one for most people.
It's 7% of 1,000.
Throw 25 in there. It's gonna be $5,427.53.
Yeah, well, that's
Oh, I was not too close. I was gonna say 60.
Anybody have trouble with buttons? My opinion, that's a pretty good deal. You put in $1,000, you do literally nothing but wait, and it's $5,000. Like $4,427 of free money for just like waiting around doing nothing. Second line is going to take a little bit of algebra equation solving because of where the x is going to locate. So 2,000, where's the 2,000 go?
After the equals.
After the equals. 9% makes us get
1.09.
1.09. The time we don't know, so throw a t on there. And then where's the 5,000?
5,000 is there.
Before the equals. We couldn't have solved this until a couple days ago. Okay? To solve when the variable is an exponent, that's called an exponential equation. The only way you can solve that is with its opposite, which is a thing called logarithms. That's why we've never done this till this year in time. So what would you do first to try to get after this?
Divide the 2,000.
Divide the 2,000. So if we divide the 2,000, I have 2.5 over there. That would equal 1.09 to a mystery power. Then log. So we would do log of 2.5, which seems weird, but that's just a number. We can get it anytime we want from our calculator. And if I'm going to do the log on the left,
Gotta do it on the right.
got to do it on the right. And then the second day we learned about logarithms was when we had logarithms and there was a power involved, we can sneak that power out in front. So the variable is doing what to the logarithm? Multiply. So algebra, we do opposites. We're going to have to divide. We're going to take the log of 2.5. We're going to divide that by the log of 1.09. A little bit of button pushing, and out comes hopefully 10.63. So again, I'm going to give you a heavy pitch on interest is your friend. You put in $2,000, you do nothing but wait for 10 years, and it's $5,000. Like, that's a fairly sweet deal. 9% is a little bit above average of a time period, but it's not exceptional. Question about the 10.63? So let's do a different group. So that's third line down. There's $5,000. Goes
Right in the equals.
right after the equals. In the parentheses,
We just put like X. Or 1 plus X.
1 plus whatever letter you like, because we don't know that one. Time,
10.
10. Out here,
10,000.
10,000. So at some point, if you wait 10 years, you could turn 5,000 into 10. Depends on the rate you get. Double your money. Solving this will not involve logarithms. Okay, why do I know, and you could know, that solving this won't involve a logarithm? What's different about this one compared to the one we're now doing?
You don't have an exponential.
It's not the power. If the variable's the power, you have to do logarithms. If the power is a number, there's another thing we could do. But before we even get to that, the first move to solve is get rid of 5,000. Get rid of 5,000, you 2, you divide. So 2 equals this to the 10th. And then how do you undo 10th powers?
Put it through it?
So let me give you a simpler version.
Oh.
If we want to undo this, if we want to undo a second power, you'd root. If you want to undo a third power, you'd cube root. If you want to undo a 10th power, you need to do a 10th root. So we're going to do the 10th root of 2, and we'll find that button in a minute. Would equal 1 plus the rate. So how would you get the rate figured out? You'd have to do the 10th root of 2, and we'll find the buttons in a minute,
Minus.
minus a 1. So there's two ways we could do this. Some calculators will have a 10th root button. Some calculators won't. So if you found your button for powers a minute ago, see if in color up above it there's some kind of a rooty button. If you have a calculator like this, forget about it. I'll take you through the menus. So if you have a calculator like this, we're going to go and hit the 10 for the 10th root. So 10, math menu. The math menu is like right below the green key,
Where it says math.
where it says math. And go down to the 5th one. The 5th button is like the any root of anything button. It has a, I have a button that looks like this.
Yeah.
So we're going to choose that button by just hitting, like selecting it, hitting enter, and putting the 2 after it, minus 1. And it's showing me a .071. If I round, it'll be an 8. Anybody need help finding buttons to get to there? Here's another way we could do it. What kind of powers are roots that we've been dealing with all chapter? Like negative powers do something. What do negative powers do?
They like flip.
Negative powers flip things. What kind of powers cause roots to happen?
Even.
No.
Positive.
Starts with an F.
Fractional.
Fraction powers do roots. You could do this as 2.
Yeah.
2 to what fraction power? 10th roots are 1/10. So you could, if you can't find your root button, you can do this as 2 to a power button and use like 1/10 as your power. That's just as good. We prefer to have percentage answers. 7.18, which based on what I've been saying is average, above average, below average?
Average.
Slightly below. Something there. Okay, then the last one of these where we're trying to solve for something, I'll sneak back this way where I have create a little more space. Before the equals,
12,000.
go to that 12,000. Principal, we don't know. In parentheses,
0.7 plus 1.
1.07. Power, 15. What math would we want to do to solve this? Try to solve for the P. Divide who by who?
12,000.
Do 12,000 divided by this whole result, which we can just do in one big swoop. Take 12, hit 12,000, hit the divide by button. 1.07, power key, 15. I'm hoping you're in the 4,000s. Anybody have something in the 4,000?
4,349.
And?
35 cents.
Oh.
Yeah, 35 cents. $4,349.35. Something about that.
How do we?
You're going 12,000 divided by
Oh, can you?
1.07, power button 15.
1.07.
I said can you go ahead.
To the power of 15.
Okay.
43.49 and some change. Anybody trouble? Top little chart. So then here's a question for you, and we'll take a quick vote. Principal versus interest rate versus time. We're going to do a base question just to get an amount, and then I'm going to double one number at a time just to show you what happens. So we're going to take a quick vote before we do that. Do you think the principal is what you'd want to double, like your amount of money you took to make your investment the day you created it? Would you rather double your interest rate? Or would you rather double the time it sits there if you're trying to get the most possible money out of this? Everybody has to vote. So hands for, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You don't have to vote. So there's 14 voters. People that would want to double the principal, you want to double your suitcase full of money you took with you to the investment bureau, that's what you'd rather double. Who wants to double their briefcase of money on investment day? Nobody. Who wants to double your interest rate instead? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 people. Who would want to double your time? 2 people. I'm going to vote. 3 people. So let's do it out and we'll see. So first line, how would you punch in the first line?
I don't know. Huh?
Would be like,
If we go to figure out how much amount of money we're going to get off the first line, what's our punch?
like,
Who's going where?
1,000 times.
There's no 1,000.
10,000.
10,000 goes here.
I keep this
Where was
We're doing the first line of this bottom little chart.
Okay. So 1 point.
So 10,000 times 1.09 power of 20. So just punch that. 10,000 times 1.09 power button 20 should be in the 50,000s.
Whoa, what are you getting?
$56,044 and 11 cents. So let's jot that in there. $56,044.11. Again, I'm going to keep making a pitch. It's a pretty good deal here. 9% is not like anything amazing, but 20 years of just wait time, $10,000 became $56,000. If you can wait.
Yeah, but I'll be dead.
If we go to do the second one, just change the 10,000 to a 20,000 and punch that. So 20,000, 1.09, still 20th power. Hit it.
I hate how you do this stuff, but I'm proud of you still. $112,088.22. Exactly what happened when you doubled your principal?
The thing just double.
You doubled your money, which is nice. I mean, if you could double your money, nobody's going to complain about doubling your money, but all that doubling your money in did is double your money out. So then let's go the 18%. So we're 10,000, 1.18, power button 20.
That's pretty big amount of money.
That is a pretty big amount of money. So all of you guys that didn't double your principal, you did pretty well for yourself by doubling your interest rate. Doubling your interest rate, you got how much money?
Like 500.
No, you're too high.
Too high? Numbers are hard.
Like 273.
$273,930.
$930. 35 cents.
35 cents. True story.
Dang.
I'd rather take out the 20.
That's like silly time. Here's the bad news. You really can't control your interest rate.
Yeah.
Like, you can't control what the stock market does. You can control your interest rate sometimes by shopping. Like right now, if I shopped around, maybe I could get a bond for 3%, a CD for 5%, or I could just hope the stock market does okay and put it in the stock market. But here's the thing about the stock market. Sometimes it goes
Up.
up, and sometimes
it goes down.
it goes down. If you want to do something crazy, you can buy Bitcoin, because sometimes that goes way up, and sometimes that goes way down, and you just don't know what it's going to do. But if you have 20 years, the ups and the downs generally create a long-term up. Final one, we're going to do a little bit better. So 10,000, 1.09, power key 40. $314,094.20. The time is a little bit more important than the rate. Here's the good news. The time is completely up to you. So if you decide someday to start saving for retirement when you're 54, that is a pretty bad choice. If you start saving for retirement when you're 21, that's a pretty good choice because you can put time on your side or make time your enemy. That's like your choice. There's a lot of things like that in life. Would you rather have a little bit of something now or would you rather have a lot of something later? That's like choices you make all the time.
Oh.
You know,
I'm at stone.
Grandma gives you $1 every time you
Oh,
see
wait,
her.
this isn't
So
bad.
every time you see Grandma, you could buy yourself a $1 item. Or you could wait until Grandma gave you $50 over the year and buy yourself like something half decent. So, I mean, you could either have 50 candy bars one at a time, or you could have like the $50 toy that you always wanted when you were 6. You know, some of you guys with jobs right now, you get paid a $100 paycheck. You could either get your $100 paycheck and get yourself a $100 item, or you could wait until you have a few of those paychecks and get yourself a car. Like, it's just a matter of, are you willing to wait for the big thing enough to forego some little things? The same thing applies to this in adult life. Question about concept? Okay, let's go to the back. I'm gonna make you a millionaire on this game.
Woohoo.
So we're going to the back, and we're gonna run a little game here of trying to think like adult world stuff that we're gonna try to set aside $5,000 a year in an adult world kind of thing. It'd be like $200 a pay probably. You know, you go through your paycheck career of a job, you probably get paid either 24 or 26 times in a year, depends on how your work works. But you set aside like $200 a pay, you'd be setting around $5,000 a year aside, and we're gonna do some math on this. So the new calculators work better than the old calculators, so we can cut some corners, and we're not gonna fill in all of these squares. We're gonna fill in certain squares. So here's what we're gonna look to do. So to first put in that $5,000, just punch 5,000 and hit enter. So your 5,000 is like in there.
It's there.
Oh yeah.
If we're getting 7%, what is this number gonna be? 1.07. So I'm gonna go times 1.07, but not hit any more buttons yet. Add 5,000 more in and hit enter. And the first starting balance for year 2 is what I just figured out, 10,350. Anybody not showing at 10,350?
I'm there. Not yet. I'm scared.
Because of the way we punch that in, every year we multiply by 1.07, and every year we
Add 5,000.
add 5,000. Since we already have that like calculation in the machine of take my answer times 1.07, add 5,000, and we got that answer. For us to progress to the next year, all you have to do is hit enter. So when you hit enter, you have a year 3 start. Don't write that down. That's 16,000. Hit enter again. You have a year 4 start.
Yep.
Don't write that down, but it's
Okay.
22,000. Let's hit enter for 5, 6, 7, 8, 9, 10. Get to year 10. Let's write that down.
I'm there. 6, 9, 8, 2.
And then let's wait a minute.
We're putting in starting balance.
Starting balance. Yeah, what are you getting?
69082.
Correct. We're going to go 69. Go ahead in the beginning of line 10, write 69082.24.
Happens. I got mine right here.
Hit enter one more time.
Yep.
Let's write that down.
Okay.
The year 11 start, let's go 78, 9, 18 even. No sense because it rounds up.
Ah.
Anybody not with us to line 11?
We're getting rich, Josh.
Yeah, just hit enter now. So year 2, hit it 3, 4, 5, 6,
78,918.
7, 8, 9, 10,
We're getting rich.
11. So, well, we want one too many. We're up to 12. Copy the 69 into that line. You have it on your screen still. The 69 line goes into 10, and then the 78 line goes into 11. Okay, so while we're there, let's do the end of line 10. Okay, so don't use your calculator though. Okay, we're gonna use our mind for this. So we have 78,000 to start year 11. how much money would have ended year 10 then?
70.
No.
Minus 5,000.
Minus 5,000. So final balance year 10 would have been 73,918. Anybody not understand the 73,918?
For final balance?
The final balance year 10 would be 73,918. Let me take a trip to the bottom of the question. We're a decade in. How much money did you personally invest that was yours in your check that you didn't buy stuff with? How much money did you put into this?
50,000.
50,000 is correct. So first question at the very, very, very bottom, you put in 50,000 bucks that decade. How much interest did you make? How much of that money is free money that came your way? $23,918. If we subtract the 73 minus the 50 that was our sweat of our brow and our labor and our paycheck, there's $23,000 of free money just got dropped in your lap for just kind of chilling.
Nice shot.
It gets better. I guarantee we're a millionaire by the time the sheet ends.
Is that the next question? Is the
No, 23,000 is the second question, yeah, 23,918. Question about that? Okay, so then let's hit enter enough times until you're at the beginning of year 21.
I don't know.
So 11.
So 10 more times.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, 224?
2,
Yeah.
3, 4.
Okay. So beginning of year 21, you'd have $224,325.88. Let's go enter, let's do some math there while we're there.
But then roll.
Okay, to finish year 20, how much money would have been there to finish year 20?
219.
$219,000 is correct. And some change, 219, 325.88. Let's go to the bottom question. Ballpark. Ballpark, how much did that just go up from the 73 to 219? Don't use your calculator because we're going to lose our punching ability, but we need somebody with a mind. Ballpark that to jump from 73 to 219. About how much?
Use your calculator.
Almost 150.
Almost 150. Let's call it 140. Close-ish.
I have a second calculator.
Cheater.
21 minus 7 is 14. 9 minus 3 is 6. So ballpark that at 146. Out of that 146, how much of that came out of your paycheck?
100K.
60,000.
50,000 again that decade.
Yeah.
Every decade we're doing the same thing. So if 146, 50 of it is out of your paycheck, how much free money did you get in decade 2?
96.
96 ballpark. So that second decade, ballpark, $96,000 free dollars. So that first decade was $23,000 free dollars. Second decade is $96,000 free dollars. Interesting point, at this time, how much total money have you put in? 100,000. And free money? 96. It's catching up. It's going to pass because it's going fast. So go back to the calculator, hit enter 10 more times.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Start of year 31, 510,000 and some change.
3, 6, 5, 22.
510, 365, 21 cents, about basically,
This
right?
is 31.
I have 510, 365.21 is what I had, but
Yeah, like at 31.
at 31, yeah. Start 31 is $510,000. So backtrack, finish 30, just for consistency's sake. Finish of year 30, we'd have $505,000. So let's ballpark this. We just jumped from 219 to 505 that decade. That's pretty bonkers, but from 219 to 505, how much did it go up?
Cool.
2,806.
Right digits, wrong words.
281,000.
Yeah, I get it.
286,000.
Yeah.
We went up that decade, $286,000 of wealth. How much of that 286 came out of our paychecks? 50. So how much did we just get for free?
236?
$236,000 for free. So third decade, you got $236,000 free dollars of just nothing happened. So let's go 10 more times, back to the machine, bumpity bumpity bump bump bump. To start year 40, you'll get a 998 show up.
Yeah.
Yeah.
So to start year 40, you got 998, 175, and 56. How are we going to finish that year? Times
Again.
to get across the line, we're multiplying by
1.07.
1.07. So just hit times 1.07, and I just put you over the million mark barely. $1,068,047.85.
Oh, I hit it, I think one too many times.
But you should still be able to see somewhere in 998.
Yeah.
Okay. And then you can just take my word for it.
Yeah.
The magic final corner is 1, 068, 047.85.
85.
So let's ballpark this
I
decade.
didn't know.
Wait, what was it?
1, 068, 047.85. So that decade, how much increase of wealth did you get? And now feel free to use your calculator because we're done pushing buttons. But from the 505 to that 1,068, how much did you bump? $562,000 of wealth increase. How much of that came out of your paycheck? 50. So how much did you just collect of free money in that last decade? 512,000 and some change dollars of nothing. Grand total, how much money did you put in?
200,000.
200,000. You did 40 times 5, you did $200,000 out of your paycheck. So how much free money did you just collect?
A lot. 800,000.
$800,000. I'm not making this up. This is how, like, money works. If you would start saving money when you're out of college at like 21, 22, that's the amount of money you would have when you're like 61, 62. Can some people save more than $5,000? Absolutely. Some people have years where you get stuck saving less than $5,000. Sometimes. Sometimes you lose your job. Sometimes you have kids. Sometimes you stop working. Sometimes roofs break or whatever. But the most important thing out of original money, interest rate, and time, the easy winner was time. Let me do something here real quick. So I'm up to where we were. If I wanted to go 10 more, I'll go like 3 more years. So 1, 2, 3 more years. 3 more years, I've got like 1.3 million. So you're like not 62 anymore, you're like 65. You got 1.3 million. 66, 67, 68, I got like $1.6 million. 69, 70, I got $1.9 million. It grows fast. What you want it to get to is that 4th decade. Like that 4th decade is where the money went crazy. Okay, but there can't be a 4th decade unless there's a, well, 3rd decade. And there can't be a 3rd decade until there's been a 2nd. And there can't be a 2nd until there's been a 1st. And you have to recognize that 1st decade wasn't that exciting. Okay, but that's called compounding interest, where your interest is making interest is making interest. At the end of this game, the interest is making way more savings than the person was. Like, the interest is what took this crazy through the roof. Question about sheet.
No, sir.
Okay, so your homework is to do a comparable sheet and to read an article. So I have an article that came out of the newspaper many years ago. It says, note to the young, invest in your 20s, relax in your 50s. And then you can read this and see what it has to say. I think it has a lot of pretty valuable information, but read that. We'll talk about that tomorrow. And then the main mathy part of the homework is a paper. It's identical to the paper we did. I just changed the interest rates a little bit. So when you're doing your investment, it's $5,000 a year again, but it's 8% interest. So your money is gonna go a little bit up. You're gonna make more than that million. You're gonna have $1 million and some change for sure on this paper. So tomorrow will be homework answer day. The other thing I'll give you today is the practice test that'll be due 2 days out. So article to read for tomorrow. Extra credit I gave you last time, also due tomorrow. Interest paper due tomorrow. Practice test due in 2 days. And I think we can cut that report off because